Hello class, so in this video I'll be going over the third of all the series tests, convergence tests I'll be doing. This one's called the integral test. So let's look at what it says. So let's consider a sum, and that we're going to have a function f of x that's continuous, positive, and decreasing on the interval from k to infinity, such that, so basically it's decreasing and integrable, such that f of n equals a sub n. So basically, if we can write the function and the sequence as the same thing. Then, if the integral converges, then so does the sum. If the integral diverges, so does the sum. So let's think about a little bit of why this works, why it makes sense. The basic idea is that the sum is like an approximation, essentially, of the area function. So if the exact value diverges or converges, then so does the approximation. Whoops, forgot to write converges. Alright. So when do you use it? Generally, if you have something that can be written as an integral and it's not too hard to evaluate, probably a good idea to just try it if any of the other tests looks a bit harder. So let's look at this and see what we can do with it. Okay, so if we look at this, then thinking about other tests, integral test probably is the best because, let's see, alternating series test isn't going to work super well. A few others might not work ridiculously well, like ratio test might not necessarily give you the thing that you want, because I think that might actually be inconclusive and things like that. But yeah, so let's just try the integral test, see how that goes. Alright, so this we can write as a function, and it will be from 1 to infinity. So 1 because that is 1. So don't just always do from 1 to infinity. 3 over 4x plus 1 dx. Alright, so this is an improper integral. So let's take the limit as t approaches infinity of the integral from 1 to t of this thing. So let's see, limit as t approaches infinity of this will be 3 over 4 ln of 4x plus 1 evaluated from 1 to t. I'm just going to move the 3/4 in front. Okay, so that'll be ln of 4t plus 1 minus ln of, I'll just make that 5. So don't forget the 3/4, just always carry that everywhere that you go. 4t plus 1 all divided by 5 because log rules. And notice that because we're using a log, t going to infinity is going to make this thing blow up to infinity, and ln is an increasing function. So this diverges, and therefore the sum also diverges. Diverges by the integral test. So always cite the test that you're using. That way whoever is reading your work knows exactly how you got to where you got, because sometimes it'll be obvious, sometimes it won't. Okay, so let's try another one. So you can see that this is going to be an integral test one because, again, some of the other ones won't work as well, and the fact that you have something inside of a function and then something that is almost its derivative, so u sub. Alright, so let's take that integral then. Integral from 1 to infinity of x squared e to the negative x cubed dx. So like I alluded to earlier, let's u sub this. So let u equal negative x cubed So du equals negative 3x squared dx. So if we want to get just x squared, we can just divide by negative 3. So let's just do this then. Limit as t approaches infinity of negative 1/3 from 1 to t, integral from 1 to t of e to the u du. Alright, let's see how this goes then. Oh wait, that's not going to be 1 to t, sorry. Because we did u sub, so we're going to have to do stuff to this. So that negative 1 is going to be plugged in there, and we get, 1, so we get negative 1. Then the infinity is now turned into t, so we just get negative t cubed. And we'll see how that goes. Alright, so negative 1/3, I'll just bring that to the very front. Limit as t approaches infinity of, so that'll be e to the u from negative 1 to negative t cubed. Negative 1/3 times the limit as t approaches infinity of e to the negative t cubed minus e to the negative 1. Alright, so this first part is going to approach 0 because you have a negative power there, and then this is just 1 over e, right? So we end up with 1 over 3e. Therefore, by the integral test, summation from n equals 1 to infinity of n squared e to the negative n cubed converges. Alright, so that's the end of this. Hopefully it was helpful, and I will see you in the next video then.